Welcome to the last video of a series where I explain the link between infection by Toxoplasma gondii and the onset of schizophrenia. In this video, I'll explain the mechanism by which the parasite might trigger the disorder. So let's get started. As soon as the parasite infects the host, the innate immune system gets ready to fight the infection. The innate immune system is composed by several different cells such as macrophages, natural killer cells, or mast cells. One of their main function is to produce cytokines such as interferon gamma. This cytokine is key in protecting us against Toxoplasma gondii, as it is capable of stopping its growth. How? Well, Toxoplasma gondii is a tryptophan auxotroph. This means that it is only capable of reproducing in mediums where the amino acid tryptophan is present. Thereby, what interferon gamma does is release a substance called indoleamine 2,3-deoxygenase, which is capable of degrading tryptophan, which will cause Toxoplasma gondii to stop growing. Everything seems great, right? It seems like a pretty much straightforward defense mechanism. Well, let me explain you how the products of this catabolic process can be extremely detrimental and might even trigger the onset of schizophrenia. The reaction products of tryptophan and indoleamine 2,3-dioxygenase are three crucial catabolites, which are L-quinureinine, quinurenic acid, and quinolinic acid. L-quinureinine and quinurenic acid are both N-methyl-deaspartate receptor antagonists. Typically, glutamate is the neurotransmitter that binds to the binding site of N-methyl-deaspartate receptor, causing the opening of the ion channel. However, antagonists such as quinurenic acid and L-quinureinine will bind to the same binding site of the receptor, forcing the ion channel to close. This will lead to a generalized function of N-methyl-deaspartate receptors, which are blocked by the products of tryptophan degradation. This receptor blockade relates to the N-methyl-deaspartate receptor hypothesis of schizophrenia that states that the hypofunction of this receptor is an important cause of positive symptoms and cognitive impairments. This hypothesis is supported by the fact that ketamine, which is an N-methyl-deaspartate receptor antagonist, mimics some symptoms of psychosis, as seen in schizophrenia. In addition, increased concentration of both quinurenic acid and quinureinine have been found in the postmortem prefrontal cortex of individuals with schizophrenia. It has also been reported that infection by Toxoplasma gondii causes the underexpression of the astrocytic glutamate transporter 1, also known as GLT1. This transporter is in charge of removing excess glutamate from the synaptic cleft. Thereby, its underexpression will lead to a surge in the extracellular levels of glutamate that, in addition to the mentioned N-methyl-deaspartate receptor blockade, will cause the accumulation of the mentioned neurotransmitter in the synaptic cleft, promoting excitotoxicity. Let's do a brief summary of all the evidence that we've discussed so far before we move on to the dopamine hypothesis. This summary will focus on two main ideas. The first is that increased levels of tryptophan catabolites can cause psychosis and cognitive impairments via N-methyl-deaspartate receptor blockade. Also, reduced levels of GLT1, in addition to the hyperfunction of the mentioned receptor, causes an increase in the extracellular concentration of glutamate that induces excitotoxicity that might lead to the development of negative symptoms and cognitive deficits, as it has been reported by several patients with excitotoxic damage. Toxoplasma gondii also changes dopamine level in its host. The parasite genome contains two genes, AAH1 and AAH2, which encode for tyrosine hydroxylase. In mammals, dopamine is synthesized in two simple steps, from tyrosine to L-dopa, catalyzed by tyrosine hydroxylase, and from L-dopa to dopamine, catalyzed by dopa-decarboxylase. The product of the expression of these genes is L-dopa, the precursor of dopamine, which suggests that the parasite is capable of producing the neurotransmitter himself. The first study that suggested a potential link between Toxoplasma gondii and dopamine found that the dopamine levels were 14% higher in chronically infected mice compared to controls. This suggests that the infection causes an increase in dopamine, similar to the increase in individuals with schizophrenia. Thus, the dysregulation in the dopaminergic activity could be another possible link between Toxoplasma gondii and schizophrenia. This leads to the end of the series where I've explained the link between Toxoplasma gondii parasite and the onset of schizophrenia. I hope it was useful and informative for all of you. Thank you so much for watching, and no worries, I'll keep an eye on new evidence about this association to keep you all updated for these videos. Any questions, please feel free to contact me.